Okay, I'm back. I'm so sorry. I had someone come to the door. So we have the weight starts at 0 and then oscillates between 5 and -5. The speed is the greatest. Remember, speed is velocity. And so we're going to be focusing on this velocity equation right here when we make this decision. And also my choices. I mean, you have choices right here. So imagine that since speed is the absolute value of velocity, this is going to be the greatest when your cosine is, the biggest cosine by itself would ever be is 1 or -1. So it's going to be greatest when cosine is 1 or -1. So we're going to say when cosine t is equal to plus or minus 1. And then when is that? When, for what t value is that? So the cosine is going to be +1 and -1 at 0, at 2 pi, actually at pi, at 2 pi, sorry, because it's -1 also. Because if you wanted to, you could split it up and, you could say, okay, it's +1 at 0, at 2 pi, at 4 pi, and it's -1 at pi, at 3 pi, at 5 pi. So you can see that it's going to be at 0, 1, 2, 3, 4, 5, ... right? ... at all of those if you said k pi for all k. So at t equals k pi for all k. Okay, so t equals k pi for all k. For all k is an integer. K is an element of the integers. And then the acceleration is greatest. Well, if we're talking about acceleration, we're going to be looking at the acceleration function. Okay, so that's going to be different. And when would this be the greatest? That's going to be the greatest when the sine of t is plus or minus 1. Okay, and so for that one, you're going to choose sine of t being plus or minus 1 because that is what your acceleration function has in it, sine. And so when is the sine plus or minus 1? Well, the sine is 1 at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, ... And it's -1, or I'm sorry, it's +1 at pi over 2. Here's where it's +1. Here's where it's -1. Here's where it's +1. Here's where it's -1. So I did that one, -1 and +1. Sorry about that. And so you can see that this is 1, 3, 5, 7 in all these odd pies, but all divided by 2. So look at that, k pi over 2 right here. Oops. K pi over 2, when k is odd, is going to be your answer for number 5. So at t equals k pi over 2, when k is an odd integer. Okay? So that is your describing motion. And I don't know if, like, this is going to be difficult for you again. I guess we could look at 18. This one gives you a position function of 3 plus 7 sine t. Find the body's velocity, speed, and acceleration, okay, at time t. So the velocity, if we take the derivative of 3, we get 0. Plus 7 times the derivative of sine is cosine. So velocity is going to be 7 cosine t. And then take the derivative of that for acceleration, this would be -7 sine t, because the derivative of cosine is negative sine. So 7 times negative sine t is -7 sine t. Oops. They're asking for speed. It's the absolute value of 7 cosine t. And then find the body's velocity, speed, and acceleration at time pi over 3. So velocity at pi over 3 is 7 times the cosine of pi over 3. Pi over 3 is 60 degrees. Oops. I think I'm going to take that off because I think that's why it's doing that. So 7 times cosine would be 1/2. So 7/2. The speed would be the absolute value of that, which would again be 7/2. And then the acceleration, so we're finding a of pi over 3, -7 times the sine of pi over 3, -7 times the square root of 3 over 2, -7 root 3 over 2. And then describe the motion of the particle. So it would start at, and its starting point is always going to be where t is 0. So if I said, what is the starting point? And I took my original equation, 3 plus 7 times the sine of 0. Well, the sine of 0 makes that entire thing go to 0. So my s is 3. So it starts at s equals 3 and then oscillates between what and what? Well, think about it as 1, 2, 3 is your center line, and you've got your 7 sine t. So 1, 2, 3, 4, 5, 6, 7. So it's going to oscillate between 7 this way from the center line and 7 this way from the center line, back up towards this. And so this is going to be 2, 1, 0, -1, -2, -3, -4. So it's going to oscillate between -4, and then if I would add 7 to this, it would be 10. So oscillates between -4 and 10. So -4 and 10 is the one that I'm going to choose right here. The velocity is greatest in magnitude when, and for these choices, either the sine t or the cosine of t is plus or minus 1. So velocity, we're talking about the velocity function here, is going to be when cosine t is plus or minus 1. And that will be at, now, our cosine is positive or -1 at, remember, pi, or 0, pi, 2 pi, 4 pi. So that's this one. T equals k pi for all k. For all k being an integer. The acceleration is greatest in magnitude when, well, here's our acceleration function. And our acceleration function is -7 sine t. So it's going to be greatest when the sine of t is plus or minus 1. And that is going to be at, we said that that was k pi over 2 when k is odd. Okay, so hopefully that will help you with the ones. And then I think I did this one with you in class yesterday. One like that, not the same one, but, and then the jerk is the derivative of acceleration. So jerk is the derivative of acceleration, which would be the second derivative of velocity, which is the third derivative of position. So they've given you a position function here, so you have to take 3 derivatives to get to jerk, okay? And I don't know if, these are going to give you trouble or not, but they do give you the equation here. So you do have to find your derivative. Derivative of 7 is 0. Derivative of cotangent is negative cosecant squared. And then minus 2 derivative of cosecant is negative cosecant x cotangent x. So that's your derivative, and they said find an equation for the tangent line to the curve at P. So you would want your derivative at pi over 2. So negative, and remember how I showed you how to do this, negative cosecant of pi over 2 squared plus 2 times cosecant of pi over 2 cotangent of pi over 2. And so pi over 2 is cosine sine, right? Cosine of pi over 2, sine of pi over 2. And so our cosecant is going to be the reciprocal of sine. So it's going to be 1 also. Our cotangent at pi over 2 is going to be cosine over sine. So it's going to be 0. Had to turn my light back on, sorry, because I can't see when it goes off. Find an equation for the tangent to the curve at P. So for this one, it would be y equals negative 1 times x minus pi over 2 plus 5. And then horizontal tangent to the curve at Q is, so we would be setting our derivative here equal to 0 to find that horizontal tangent. So 0 equals, and I would factor a cosecant x out. Oops, forgot my C. And I'm going to put this 2 cotangent x minus cosecant x together, only I put the positive one first. But if you distribute it back, you would get back to what you started. And if we did 2 cosine x over sine x minus 1 over sine x here, well, this cosecant on the outside could turn into 1 over sine on the outside too. And so that becomes 2 cosine x minus 1 over sine squared x. And where is it 0 is going to be where this is 0. So you're going to say, well, that whole thing is going to be 0 when that numerator is 0. So 2 cosine x equals 1, cosine x equals 1/2. Where is the cosine 1/2? Well, that's positive, so it's in the first and fourth, and that is adjacent over hypotenuse. So this has to be square root of 3, this has to be 60. So this x is going to be pi over 3 and 5 pi over 3. And when you look right here, it's right at 1. It's actually exactly on 1. And that's where our derivative is 0. And what is pi over 3? That's like almost 1. I mean, it looks like it's on 1, but if you were looking and you said, okay, well, what is like 3.14 divided by 3? It's like 1.046. So, and you would throw out 5 pi over 3 because of where it's located. So Q is the point pi over 3, comma, and then you could find, I don't know if it's going to end up being 5, or you would put this into your y, 7 plus the cotangent of pi over 3 minus 2 times the cosecant of pi over 3. And we said, oh, it's right here, 60 degrees. The cotangent was 1 over the square root of 3. And the cosecant is going to be hypotenuse over opposite, 2 over the square root of 3. So this is a -4 and a +1. So this is a -3 over the square root of 3. So 7 minus 3 root 3 over 3. So my y is 7 minus the square root of 3. So this is going to be 7 minus the square root of 3. And that should be close to 5. And if I go here, 7 minus root 3. Look at that. It's very close to 5, 5.2679. And on this picture, it looks like it's at the point 1, 5, but it's not. Okay, so you have to be careful for that horizontal tangent because it's very misleading. So the horizontal tangent to the curve at Q is y equals, well, it's going to be y equals whatever that y value is. So it's going to be 7 minus the square root of 3 because it's going to be the y value of this point right here. And let's go down 23 and check our answer. And there's our answer. We were correct. Okay? All righty. So I don't know if there are any more. I think we got through quite a few, and you're probably, you can probably do the rest by yourself. But please let me know if you need anything. I did put a study session up for 3:30 today.